Number 2, the question is, class the definitions of properties of stochastic processes. The first one is stochastic, the Hw10 stationary process. A stochastic process is called Hw10 stationary process when its mean is a constant and the autocorrelation is a function of time difference. The WSS only defined by the mean and the autocorrelation. Number 2 is independent increment process. It means xt1 minus xt2 and xt3 minus xt4 are independent on non-overlapping intervals. When xt1 and xt2 don't overlap with xt3 and xt4. Actually, when xt2 is less than xt3 and xt1 is also less than xt3, it's non-overlapping. Or otherwise, a Markov process. The definition is if the past has no influence on the future when the present is known. Number 4, normal process. A process xt is said to be normal if the random variables xt1, xt2, blah 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 to xtn are jointly normal for any n, any t1 and 2tn. Number 5, a process is said to be a strict stationary process if its statistics is not affected by a shift on the time axis, which means fx of x1, x2, blah blah blah, xn, t1, t2, blah blah blah, tn equals to fx of x1 to the xn, t1 plus sigma, t2 plus sigma to tn plus sigma is the same. Number 6, white noise. A statistic process Vt is said to be white noise if the expected value is 0 and the autocorrelation is Qt1. The jump function t1 minus t2. And a statistic process xt is said to be mean ergodic process if, according to the definition, when t goes to the infinite value, the limit the value of 2 or 1 over 2t times the integration from minus t to t times x of xt dt equals to the ext. 8. A statistic process is said to be martingale if ext when xs equals to x1 equals to x1, where s is less or equal to t.